Column reinforcement details. What are the column reinforcement detail requirements? Minimum reinforcement area, maximum reinforcement area. How to provide the reinforcement in columns. How to lap reinforcement. How to crank reinforcement. All those will be discussed today. I am Prasad from Structural Guide. Please subscribe our YouTube channel. You may get the notification on new videos. Reinforcement detailing of the columns. Today we are going to discuss this requirement based on the BS 8110 and Europe code. Requirement basically we discuss based on BS 8110. Column is a very important structural element when compared to the other structural elements, and also it's in addition to the foundation, column is the most dominant element in the structure. Beam or slabs could fail. Failure of a beam or slab could not lead to a wall structural failure, but failure of a column may lead to a progressive collapse. With that, wall structure could fail. Therefore, we have to be very careful in designing detailing of reinforcement column or any type of column that support a structure. Reinforcement detail requirements. According to BS 8110, we have to provide minimum reinforcement area. 100 AS over AC equal 0.4. That is 100 AS means reinforcement area minimum. AC is the cross-sectional area of the column. That should be 0.4. The maximum reinforcement area from the cross-section of the column. Vertical cast columns we have to maintain at 6%. Horizontal cast columns, if we have horizontal place columns, it should be about 8%. Laps in vertical and horizontal cast columns, you should not exceed the 10% from the cross-sectional area. So these limits should follow when you are doing the reinforcement detailing. The maximum limits should not exceed because there will be issues in the structure. Reinforcement links. So there are special rules for providing links or stirrups in column reinforcement. Link diameter. Generally, the link diameter shall be at least 1/4 of the size of the largest compression bar or 6 mm, whichever greater. Link spacing. Maximum spacing shall be 12 times the smaller bar diameter. All the column reinforcements should have at least one link passing them. At least one should link touch all the column reinforcement. That's a rule. You can't place the reinforcement, isolated reinforcement in the columns. No rebar in the column should be further than 100 mm from the restraint bar. That is, if a reinforcement bar spacing is more than 150 from the restraint bar, that bar need to be restrained with links. What does this mean? Now, if you go to the corner column, this is restrained. This bar is restrained because we have links from the both side. Now this bar is not restrained. So if this spacing exceed 150, okay, this is greater than 150, this gap greater than 150, then such a case you have to restrain this bar. You can put strap like this, or you may put single strap, but it may be difficult here because you can put like this, but this also we have to put another one like this. So therefore it may be difficult, but we have to provide. So whatever, if you may have a several you see several rebars like this, say these are rebars like this. In a large column there may be several rebars. Now if this gap is 100 more than 150, we have to provide. Say this is, if this is, say this gap is 100, so this bar you don't want to restrain by link if it is 100, but when it comes to this bar, if this is greater than 150, you have to provide a link for this. So that is the practice you should follow in detailing of the reinforcement of the columns. Links. Reinforcement lapping. So what do we need to consider at lapping? So there are two type of laps are there: side laps and vertical laps that need to crank the reinforcement. In the side lap, you don't want to crank the reinforcement. If you have adequate space, you can do the side lapping, except the corners. Corners, you have to always crank the reinforcement. So in the middle bars here, as you can see here, if you have adequate space for these bars, if you have adequate space, you can crank, you can put the side lap here. So you have crank here now. If you have adequate space, you can put a straight bar there. That depend on your spacing in the column reinforcement. One more thing, important thing you have to mention, we have to mention here the crank length. So crank is you have to maintain at least about 1:10 slope there. So you may keep such a gap there for the construction requirement and other needs. And also you have to lap the reinforcement staggered manner. We'll discuss these things in next slide also. Apart from that, you have to be very careful about the cranking or reinforcement. You have to maintain the standard slope. In addition, as a best practice, at this bend, you may provide additional link as you can show here. So at the bend, you may provide 3 links at a spacing of 75 millimeter. Other links from there to there, those links you may follow the regular spacing. But here you may provide the additional links. So rebar lapping, if you want to discuss further, now you can see here in the bottom cross section of the B. So this here the the continuing bar and the new bar is indicated here. Now you with that, now if you have a, as I mentioned previously, if you have a sufficient gap here, so you can have left reinforcement left here also if you have sufficient gap, and the design requirements, if that satisfy the design requirement, you can put the side lap. Unless you can't reach that, if you can't reach that, you have to provide cranking like this, because if you have a link like this, you can't put the side lapping, and then you have to crank this bar. In addition, now we have to keep in mind, now when you're doing the detailing, if you lap the reinforcement at the same point, now here you can see here you lapping the reinforcement at the same point here. So this place we have lap over the bars. Now for smaller columns, this is not that much of issue, but when the column sizes increases, the reinforcement congestion also increases. In such cases, better to stagger the lap. You may have a lap, certain number of lap here, other laps you can shift. That's the best practice that you can use in the construction. So in the design also, you have to do the design and you have to do the detailing of the reinforcement accordingly. With that, you have reduced the complication, and also the strength of the joint also increase, because when you have a cyclic loading that caused by the earthquake or any other similar kind of a load, in such a case this failure is caused to the joint and also at the joint. If you have done correctly detail in the joint, and then just above the joint the bending will be higher, so this area would fail easily if you have a weak joint here. So if you can avoid the laps, or if you can move all the laps to upper, it's better, but practically it may be difficult. So you may laps less than 50% of the reinforcement lap here. You most of the reinforcement you can lap at the mid high. It's the better where the bending movements are smaller in columns. Column size change. When you reduce the column size, what we want to do now, as you can see here, you have to maintain the adequate cover for the beam reinforcement and all that. So this gap should be maintained. You have to check the beam reinforcement arrangement, etc. Then with that you have to do this bending or this height, you have to finalize accordingly. In addition, when you have a new column having a smaller size when compared to the column came from the bottom, you may have to have a new reinforcement. So you have to do the design and you have to provide the, now you do the construction up to this level. So beyond this level you can't. So if the best practice is you can put the starters as shown here. You can put the starter bus there, then you can lap the reinforcement and continue. because during construction if you have put a long bar there, it may be very difficult to hold here, and there may be chances of the movement with the wind and etc. There will be movement, so this joint will be weakened. Therefore you can put a starter bars there and you can lap later. Also, you have to keep in mind to provide the additional reinforcement like this. You can see here this figure. So you have provided the additional reinforcement bar there. So this is the new starter bars goes into the old or the terminating column. Then here you have provided the additional links. Here you have provided the additional link. So these links in addition to the reinforcement or shear links from the main column. You need to put these additional links in this area. This is because now this load will be applied to the center of the column. There will be tensile stresses develop and confinement issues will be there. Therefore you have to provide column strap there. In addition, you have to follow the spacing requirement for shear links. With that, we are in the today discussion. Today we discuss about the column reinforcement, lapping arrangement and all that. How do we do the lapping and what are the reinforcement requirement and what are the maximum area of reinforcement, what are the minimum reinforcement areas. All those were discussed today. Let's meet again from new video. Thank you very much.